quickly go through this presentation just to give you guys a little background and also explain some of my methods, and then we'll look at the code that I wrote for this program. So basically, I'm Nathan G, and what the objective of this paper is to identify bias and false information, specifically in political media, to better help people understand what exactly they're reading. Is it false? Is it biased? Especially during the US political climate, like nowadays during the Trump presidency and still during the Biden presidency, we've seen there's a lot of fake news, a lot of biased news being thrown about. And that is one of our major focuses for this is like, how can we combat that, this extremely prevalent problem that is developing where we have a lot of bias and fake news within the media, and how do we make sure that the people of America can make sure that they are able to understand what is accurate and what is inaccurate, so that way that we can establish, the fundamentals of democracy, because everyone needs to be informed correctly through getting accurate information. So our hypothesis here is basically we're going to try using regression and classifier models to evaluate linguistic vector maps and frequency detection to find bias and falsehoods in political media. And we'll go ahead and digest what specifically that means in the following slides. So we have two major ideas right here. We have natural language processing, as you heard probably from the last presentation. It's just how computers interpret language. We use natural language processing a little bit differently in this paper. And then also we have supervised machine learning, which is basically using training and testing sets to basically train a model to be able to identify either some kind of binary result, either fake or not fake, or biased or not biased. And that's kind of the idea of supervised machine learning. And additionally, in the actual cases we're using regression and classifier models. And those two would both rely on adjusting weights for more accurate results in different nodes and in different parameters. So these are basically a visual representation of both logistic regression and a random forest classifier, which are basically the two supervised machine learning models that we used. So as you can see, we have a logistic model, which is the blue, the orange line to your left, or it might be mirrored, so it might be to your right. But basically what we see here is that our data is going to be basically imaginarily plotted by our computers, such that there are a bunch of different points on a graph, and then a cluster of them will be biased and a cluster of them won't be biased. So the question is, how do we separate them? Well, a primitive approach would be a linear model, just basically just draw a straight line to separate them. But of course, that might not work for some more advanced cases. So here we turn to the logistic model, which you basically see we have the parameters that we can alter are B0 and B1 within the actual function. And basically what it does is that each time the model finds a correct answer, it keeps those weights. But each time it finds an incorrect answer, it slightly adjusts those weights to ensure that the actual logistic model will slightly move. And then therefore, at the very end, we should have a fairly accurate result of what is a fake or what is biased, depending on where it is, depending on the line. And also we have a random forest classifier, which is basically a bunch of trees, or which is why it's called a forest. But we have basically trees that we send through, and then they go through a bunch of nodes, and then it gives a prediction. You average all those predictions, and that would be the random forest classifier. So this is the general flow chart that we used here. So basically, we're going to start off with a political article right here, and then we're going to scrape them from the web and then split them into sentences, because obviously each one has to be evaluated independently. And then this is where the models come in. We have a total of 4 data sets, and they're synthesized in different ways. So we'll go over them later, but basically what you can see here is that the annotations model is how we predict bias, and the UCSB false and Cornell convo data sets are used to determine false results and political ideology. So so for political ideology, what we're looking here at is obviously the conservative liberal type idea, where basically there are, two political parties in the US. It's the Democrats and the Republicans. Democrats tend to be more liberal and the Republicans tend to be more conservative. And we're trying to see that if it is indeed biased or fake, who is it biased in favor for? Because normally that's how it works. Like you've heard of like Fox News being like biased for like conservatives, and you've heard of like MSNBC being being biased towards liberals. So that's kind of the idea of these three results, and then we obviously return the values to the to actual people, and then we basically list what sentences are false, which one are biased, and what type of bias it is. All right, so we're going to really quickly go over our natural language processing methods. Essentially, what we have here is that there's going to be a list of sentences. And now supervised machine learning models, they can't deal with the sentence. They don't know what words are, right? We have to distill them somehow into numbers. So that way that the supervised machine learning, especially data science, can be able to actually understand what is going on. And therefore, they can find certain patterns that humans can't see, but the models might be able to see and catch on to. So we use something called a TF-IDF transformer and a count vectorizer. So on your right here, the figure here is the count vectorizer. Basically, what the very first thing we do is that a list of sentences come in, and then we just put them in a table and see how frequent they are. As you can see on the table, it's very simple. Like we have all the words, and then we have how much frequency there is, right? And then after that, what we do is we put it through the TF-IDF transformer, which is basically a mathematical model that tries to evaluate every single word in terms of its impact on the article. However, there are also it also takes into account that there are certain words like this or like is, and then they happen a lot and we really don't care about them. And they're like linguistically called stop words. And we want to try ignore those, right? Because obviously we're evaluating a false or biased sentence. We don't really care if it uses like is, the, or certain articles. So the reason why we chose to use the TF-IDF transformer is because it makes sure that through like using a logarithm that these certain features are not actually really emphasized. So then after that, we would feed this into our model, and then that numericalizes the data for us, and then we can actually train the models. So each data set, I'll show you more in depth in the code, but these are basically what the data sets are. They, of course, are compiled by humans because naturally we want these models to sort of like model like some kind of like political science professional or political science professor and their professional opinion of whether this is biased or fake. And then we can sort of use that as a metric for our models. So on the screen there is what each data set is from. Okay. So these are the general results here. As you saw, there were 4 models in the flow chart, and basically each one had an average accuracy running 10 times, a mean absolute error, and then an F1 score. So the average accuracy, like if there was one that was a lot lower, and that was the ideology one, which I'll go over later. But there are basically a bunch of 70%, which are about on par for bias news, because bias is obviously a kind of subjective, and it is rather difficult for a computer model to get anything above like an 80 or 90. And then obviously we also have mean absolute error. So basically how it's evaluated is that each model returns a 0 or 1 for whether it's biased or false. So the mean absolute error means that in the actual prediction, how far away was our prediction from the actual result, right? Because that's the mean absolute error. And as you can see, they both were under like about like 0.26 to 0.29, except for the one outlier there. And that's generally because of the fact that sometimes certain sentences are going to be more biased than others, and that's how that kind of mean absolute error is generated. And the F1 score is obviously the harmonic mean between precision and recall, which is basically telling us, well, how accurate is this? Like, is it just getting like certain swaths of this wrong? Is the accuracy like statistically reliable? And since they're about over 0.75, we can just assume that they are, because this generally tells us there are not too many false positives and false negatives in the data set. Okay. So we'll really quickly go over the code and then go back to the reflection area. So that's just all the imports. So here is the synthesization of the first data set. So what we actually do is we take Wikipedia sentences, which Wikipedia is obviously it is technically a dictionary. So we automatically assume that those sentences are true sentences, right? Like they have no reason to be biased, and then they are generally true. And then what we can do here is that we can generate a data set of technically non-biased sentences that could be whatever. They could include proper nouns, numbers, and as you can see here, most of these sentences make absolutely no sense, but they are technically all factual. It's like doctors have been prescribing these processes since the 1950s, obviously a factual sentence, which we need to also add in because in political news, there are sometimes some like explanation sentences. Like when it comes to like COVID-19, it's like, oh, COVID-19 is a member of the coronavirus family, which is a very common sentence that you might be able to find on Wikipedia. All right, so we'll go back to that later. That was just read in first, but this is the Cornell Convo data set. Now, the Cornell Convo data set is a very interesting data set because it basically is a compilation of the Senate debates in 2006. So how it's organized is that it has all the dialogue between all the senators, and then the senators are given a name, a tag for Republican or Democrat, and what they have said. So we read that in, and then obviously we're going to try to use this in a model. However, there's a slight caveat to this data set. Since this data set is not political media and it only shows us the actual Senate debates, there are a lot of sentences we simply do not care about. As they're like in the actual data set, there are probably millions of instances where a senator just says, "I yield my time to the chairman." And that's just generally like the general proceedings that are still in the data set, but we don't need them for our actual evaluation of our model. So what we end up doing is we use bigrams. So what we do is we split every sentences into a set of 2 words and then check for their frequency. So as you can see here, we split them into Democrats and Republicans. We have a bigram for each of these, and then we append them to a data frame, and then we run the model. So basically what this is able to do is that we want the model to generally view each bigram as a Democratic bigram or a Republican bigram. An example given by the actual Cornell Convo data set is that like the term illegal alien, which was used a lot in 2006 by Republicans, was like pretty much a dead giveaway that the senator was a Republican. And then if it was like free healthcare or something, that was not only like a pretty much dead giveaway that it was a Democrat, but it was almost always Bernie Sanders as well. So generally we can see those patterns, and then obviously our model can see even more patterns, which is kind of the idea behind this. However, there is something to be noted that this model is not necessarily the best because it does not have a very high accuracy rate, and that is particularly because a lot of the bigrams are very difficult to determine between each other. And what you would have to do is you would have to probably use this year's Senate debates, which I don't know if they have the dialogue, but that would have been much more useful for our other models. All right. So the annotations data set is a data set made by 10 annotators. These guys are basically like people who have degrees in political science, and they are generally able to determine whether a sentence is false or biased. And then what these 10 annotators did is that they just looked at each sentence, labeled it non-biased or biased, and then moved on. So as you can see here, we read it in, we drop some columns that we don't need because a lot of that is like information about the annotators and stuff. And then this is where we add the Wikipedia sentences because we found out that this data set is actually skewed towards bias, as in there was way too many bias terms and not enough non-biased terms. So the data set was skewed, and that was creating a lot of problems for our model. So we filled in the non-biased data set with our Wikipedia sentences, so that way it's balanced. And then that way we have a completely balanced data set. And as you can see here, the data looks something like this. We have a bunch of non-biased. These are very like, irregular sentences. And then we have some more like a bias sentence. So like in this one, number sentence 19, Trump, who ran on a promise to build the southern border wall, used the outbreak as another opportunity to attack Democrats' position on immigration and border security. This was viewed as biased towards Democrats because obviously this is painting Trump in a bad light because they used the word attack. And this was kind of the idea of what we're using in our model. And then you can see here that there are much more data. I believe there are 17,000 sentences in this, which are all about like this. All right. So then obviously we use the train test model used by sklearn, and then we use logistic regression here with our two natural language processing models that we used beforehand. And then this had actually a much higher accuracy, a much higher F1 score. And this in general should be able to predict bias in most instances. And then onto our UCSB model. The UCSB model was basically a project created by the professors at UCSB to create a data set for false information. So in this, what we have here is that we have fake, right? Fake information. So the key difference between fake and biased information is that biased information presents the actual facts, right? It says like this and this happened, but it paints it in a sort of bad light or a good light, which shouldn't have been there if it was completely non-biased. Fake, however, is just a totally different scenario that was like not even real and it is not a fact. So that is kind of what we want to focus on now, because obviously it's completely fake information needs to be addressed first, and then we can see if it's biased. So in this, it is very similar to what we did beforehand. We read it in, and then we train test split, and then we use a logarithmic model. And this gives us about a little bit higher accuracy, but also a much higher F1 score, which means that in general, it will be more statistically reliable and it's not necessarily prone to overfitting in the model. And then we also test a random forest classifier for the same model, and that pretty much returned almost identical results, showing that there is really no difference between using a logistic regression model and a random forest classifier model for this specific problem. So yeah, these are one of the results, and then we would save our models here. So like in the end, what we basically saw was that there was a lot of pretty good breakthroughs there, because we were able, for the most part, to be able to tell whether a new sentence was biased or it was false. But there are a few problems in increasing the accuracy. So there are actually quite a lot of future developments that I am looking into. One of them was actually the usage of more advanced social science techniques. So one of the propositions made in another social science paper that didn't look into actual computation, but just speculated, was the use of news aggregators. So we would basically have like 10 articles reviewing this same exact event and see how they compare. So for instance, if it was like a speech that Biden gave, we would have like 10 articles from different news sources with different levels of bias to evaluate whether or not that talking about that speech, and then we would use a bag of words and compare them all to see whether or not there are some that are more biased, what words they use more often, is the semantical analysis of these like different, is one particularly negative or positive, and that is kind of another approach you can take. But another just straight up development onto the actual code that I've written is to create bigger data sets. So bigger data sets are obviously much better, because one of the major things that they do is they prevent overfitting in our models. And overfitting is actually a pretty big problem for natural language processing models specifically, because natural language processing does kind of dull the words to become numbers, and that there is indeed something lost in between there. So that is why a bigger data set would be very helpful, and it would also provide more accurate results because we'd be able to train our model further. But another idea that was used was actually using a neural network with higher dropout. So that way, if we use like an LTSM neural network, for example, we would be able to like use long-term learning to figure out certain patterns that we may not have seen last time. And that is also kind of another concept that would be a straight up improvement on our current model. And additionally, there is also the very simple source analysis, which basically says, oh, this is from Fox News, so this is probably going to be conservatively biased. But the problem with that is that we're using like kind of a pretty big assumption right there that all the news articles from this area is like are conservative or liberal bias, which is why I chose not to do it in this paper, but it could possibly be used for further research. So the general importance of this research is that like fake news is a pretty big problem in the US. What it does is that it does create a pretty big cultural and political divisions that lead to like polarization. As you see from the January 6th insurrection, that is a very big deal right now. That was actually generated primarily due to fake and biased news about the election being stolen. And there are very tangible impacts to this research. if people are not able to get that accurate information, we see the violence in the real world that actually will happen as a result of a not incorrect information reaching people's houses that shouldn't have happened, right? The January 6th insurrection maybe would not have happened if the people who were attending actually got the correct information and got non-biased information. And that is one of the key importances of the research application here, is that we need to be able to prevent these kinds of events from happening again. And one of a very good solution to this that is very hands-off and which is generally very good for American politics is getting rid of fake news and biased news, or at least helping the American public learn what is a fake and what is biased. And that will generally create very good results. And so that would be the end of my presentation. And thank you for listening.